Hello, curious minds. Have you ever stared up at the sky and asked yourself, why is the sky blue? It's one of the most beautiful and seemingly simple questions, but it holds so many layers of science, history, and even philosophy. Today, we're going to explore the fascinating journey behind why our sky is blue. We'll discuss the physics of sunlight, the interaction between light and the Earth's atmosphere, and how our eyes perceive it all. But that's just the start. We'll take you deeper, exploring how this knowledge has shaped art, culture, and even the way we see the world. Let's start with sunlight. The sun, that huge ball of gas 93 million miles away from us, is our main source of light. It might look white to the naked eye, but that's because it's a combination of all the colors of the rainbow. But how can we see this? When sunlight passes through a prism, it splits into 7 different colors: red, orange, yellow, green, blue, indigo, and violet. Each of these colors represents a different wavelength. The shorter the wavelength, the more it interacts with the atmosphere. This is crucial in determining why the sky is blue. Now, let's look at the broader electromagnetic spectrum. Beyond the visible light that we see, sunlight also emits ultraviolet, UV rays, infrared light, and other forms of radiation. While we can't see them, these wavelengths interact with the atmosphere in different ways. Visible light, however, ranges from about 400 to 700 nanometers in wavelength, and within that range, blue light has the shortest wavelength. That's why blue light is scattered more than other colors. Next, let's dive into the atmosphere. The Earth's atmosphere is a mixture of gases, mainly nitrogen, 78%, oxygen, 21%, and trace amounts of other gases like argon and carbon dioxide. The molecules in the atmosphere play a significant role in how we see the sky. When sunlight enters the atmosphere, it collides with these gases. This is where Rayleigh scattering happens. Rayleigh scattering occurs when light interacts with particles that are smaller than the wavelength of the light. Since blue light has the shortest wavelength, it gets scattered more easily. This scattering causes the blue light to spread out in all directions, and that's why the sky appears blue. Now let's explore how our eyes perceive all this light. The human eye contains 3 types of color receptors in the retina: red, green, and blue. These cones work together to allow us to see a wide range of colors. However, our eyes are more sensitive to blue light, which is why we see it more vividly than the other colors. Additionally, the violet light, which is scattered even more than blue light, is not as visible to us because our eyes are less sensitive to it. This is why we see a blue sky rather than a violet one. As light travels through the atmosphere, it encounters different particles, including dust, water droplets, and air molecules. The varying size and density of these particles also influence the way light scatters. For example, when there's more dust in the air, such as after a volcanic eruption, the sky can take on a reddish hue due to less scattering of blue light. Understanding these interactions helps us understand why the sky might appear more intense on certain days and less so on others. Have you ever noticed how the sky turns beautiful shades of red, orange, and pink during sunrise and sunset? This is because of the angle at which the sun's light passes through the atmosphere. During these times, the light has to travel through a much thicker portion of the atmosphere. The shorter wavelengths, like blue and violet, get scattered away, leaving behind the longer wavelengths like red and orange. That's why sunsets and sunrises are so warm and colorful. The blue sky is not unique to Earth. Other planets have their own skies too. Mars, for example, has a thin atmosphere composed mostly of carbon dioxide and dust, which scatters sunlight in a different way. As a result, the Martian sky is reddish. Meanwhile, Saturn's moon Titan has a thick atmosphere filled with organic molecules. This creates an orange-brown sky, giving it an entirely different look compared to our blue sky. Each planet's sky is colored by the composition and thickness of its atmosphere. Beyond the science, the sky has always been a source of wonder and inspiration in art, poetry, and philosophy. For centuries, humans have gazed at the sky and tried to make sense of it. The sky's colors have symbolized everything from hope to melancholy, from vastness to mystery. Philosophers like Aristotle and later scientists such as Lord Rayleigh have pondered why the sky looks the way it does, linking it to the very nature of the universe itself. In the 19th century, Lord Rayleigh made a groundbreaking discovery about light scattering. He found that the intensity of scattering is inversely proportional to the fourth power of the wavelength. This is known as Rayleigh's law, and it helped us understand why shorter wavelengths, like blue, scatter more than longer wavelengths. This discovery led to a more detailed understanding of the natural world and helped confirm the reasons behind the blue sky. Want to see the science in action? You can conduct a simple experiment at home to visualize Rayleigh scattering. All you need is a flashlight, a glass of water, and a little bit of milk. Shine the flashlight through the glass of water and observe how the light scatters. You'll see the same effect that makes the sky appear blue. Throughout history, the sky has inspired artists and poets alike. From Van Gogh's Starry Night to the poetry of Rumi and Khayyam, the blue sky has been immortalized in countless works of art. In modern times, scientists and artists alike are drawn to the sky as a symbol of the mysteries of the universe, inspiring us to continue exploring its beauty and complexity. Today, scientists use advanced tools like LIDAR, spectrometers, and satellites to study the sky in even greater detail. These technologies help us understand not just the color of the sky, but also how it changes over time, how air pollution affects it, and how climate change may alter the way we experience the sky in the future. Imagine a world with no atmosphere. The sky would be pitch black, even during the day, and the sun would appear as a bright, harsh point of light in the black void. Without the scattering of light by atmospheric particles, there would be no blue sky at all. It's a stark reminder of how essential our atmosphere is to the beauty and livability of our planet. We've journeyed through the science of sunlight, the intricacies of Rayleigh scattering, and the amazing role our atmosphere plays in shaping the color of the sky. We've also explored how the sky has influenced art, culture, and even philosophy. The next time you look up at the sky, remember all the science, history, and beauty that lies behind its color. The blue sky is not just a backdrop for our lives. It's a reminder of the wonders of the natural world and our place in it.